Hi, and welcome to Lesson 3.1, Arcs and Angles. So all of Chapter 3, as you can tell from the title in the upper left, will be focused on two different main ideas, one being angles, the other being lines. Now, within the idea of angles and lines, we'll be looking at things like arcs, rotations, translations, slides, and so on. Today, obviously, we're just talking about the idea of arcs and their relationship to angles. Now, remember, an angle we can describe in geometry as the union of two rays, where they both share the same starting point or end point. And in that case, that creates our angles. Now, an arc is a set of points made up of 2 points on a circle. So we would represent that with this curved piece above the two endpoints. So if it's arc xy, we would write that as this curve over xy, reading arc xy. We could also name it arc yx, just like a line segment. You can flip the order of what's underneath the symbol. Now, the measure of an arc is given in degrees, and it's the amount of the circle that's traced by the arc. So if I'm looking down here at circle A, and we have arc BC traces half that circle, so it's a 180-degree arc. Then a semicircle is a special arc whose measure is 180 degrees. So arc BC is also a special arc known as a semicircle, and the endpoints are the diameter of the circle. So if I'd connect B to C with a line segment through the circle, it would create the diameter of the circle. Then we have a minor arc. Minor arc is an arc with a measure less than 180 degrees. And we name our minor arcs with just the two endpoints. Then we have a major arc. And a major arc is an arc whose measure is more than 180 degrees. And we name our major arcs with 3 letters. So if we look at our circles over here, if I were to go around one of these circles from K to L to I could write that as arc KLI or arc ILK. So we're always using 3 letters. Then when we go down to example 1, name the 2 arcs determined by the points IK in circle H above and give the measure of each arc. Now circle H is over here on the right. We always know the name of a circle based on the point in the middle. So this would be circle D, circle O, circle A, circle H. So in circle H, we want to name the 2 different arcs that have endpoints of I and K. So one way that we could go is from I to K this way. So I to J and then J to K. So arc IK is actually arc IJ plus arc JK. So IJ was 30 degrees, JK was 102, so arc I to K is 132 degrees. Now, if I were to go around the other way, from I to K this way, or K to I that way, we have point L in the middle, and it's a major arc. So we could name this arc ILK or arc KLI. It's the same arc. And in this case, arc ILK measures 228 degrees. Then we move down to this idea of an angle. So again, an angle is a union of rays that have the same endpoint. The rays make up the side of the angle. The intersection of the rays, so that shared endpoint, is our vertex. Now, the way that we name an angle we can name an angle with a single number if they provide a number in the angle. We can name it by just the vertex if that vertex is not shared with other angles, or the 3 letters with the vertex in the middle. So if we're looking at this angle drawing here, I could name this angle 3 because of the 3 in it. I could name it angle ABC or angle CBA as long as the vertex is in the middle, or I could simply call this angle B. So different ways to name an angle. Then we have a central angle, and a central angle is when the vertex of an angle is the center of our circle. So when the vertex of the angle is also the center point of our circle, we have a central angle. Now we have our definitions of different types of angles. So one classification or type of angle is a zero angle, and that's an angle with a measure of 0 degrees. We have an acute angle where the measure is between 0 degrees and 90 degrees, not including 0 or 90. We have a right angle whose measure is exactly 90 degrees. An obtuse angle, measure between 90 and 180, not including 90 or 180. And then a straight angle whose measure is 180 degrees. So then in example 2, they want us to use the figure at the right to answer the following questions. Give 2 other names for angle BAM. So BAM. Well, BAM would be angle 1, so we could call that angle 1, or we could call that angle MAB. We could not call this angle A because A is the vertex of both angle 1 and 2, so we can only use the number or the 3 letters. And then to classify angle MAC, so angle 2 here, is it a zero angle, acute, right, obtuse, or straight? The measure is less than 90, greater than 0, so we would have an acute angle. And then it says here, use circle O at the right, which is down on our next page. So we'll be using circle O for example 3. So it says in part A, find the measure of angle ROS. So now here's the nice thing when we're dealing with a central angle. The measure of the arc created between R and S is also the measure of the central angle ROS. So if RS is a 32-degree arc, our angle ROS is a 32-degree angle. Now find the measure of arc RTS. So from R all the way to T, all the way to S. Well, if we know a circle is 360 degrees, and we know the missing piece is 32 degrees, which is RS, we can do our whole circle minus RS, and we're left with the measure of the major arc, RTS, which is 328 degrees. And then we move into our angle measure postulates. So in our angle measure postulates, or our angle measure postulate, I should say, it's made up of 4 different assumptions. So these 4 assumptions from A to D make up our singular angle measure postulate. So the first part of our postulate is the unique measure assumption, which simply says every angle has a unique measure from 0 to 180 degrees. So every angle can be measured 0 to 180. The unique angle assumption says given any ray VB for a real number R between 0 and 180, there's a unique angle BVA on each side of VB such that the measure of angle BVA equals R degrees. So in other words, given ray VB, so we have VB here, and then we have point A up here. In this case, what this is saying is that we can measure BVA based on the number of degrees to get its angle assumption, or the unique angle assumption. Then in C, we have the straight angle assumption, which says if VA and VB are opposite rays, the measure of angle BVA is 180 degrees. So a straight angle would be something like AVB or BVA. And then the zero angle assumption says if VA and VB are the same ray, so V to A and V to B are the same ray, then the measure of that angle, BVA or AVB, are 0 degrees. And then we get to this final idea of an interior or exterior of an angle. The interior of an angle is the space that's in between the two between the two rays and the vertex. So if the two rays are our sides, the interior is all the space in between those two rays. The exterior is everything outside of those two rays. And then we get to our final idea for today. It's this idea of assuming or assumptions from drawings. So there's different things from a drawing that we can simply assume or not assume without extra labels or information. So from a figure, so from a simple drawing, we can assume the collinearity and betweenness of points drawn on the same line. So if they draw them on the same line, like looking down here, A, T, I, E, and L, we can assume those are all collinear. The intersections of lines at a given point, we can assume that. So we could assume line T here intersects line N at the given point of I. And then we can also assume points in the interior of an angle, on an angle, or in the exterior of an angle. So if I'm looking at angle JIK, I could make an assumption about points on the interior, on the angles themselves, like JI and K, or on the exterior. Things we cannot assume. We cannot assume collinearity of 3 or more points that are not drawn on lines. So if they did not give us the lines, we cannot assume they're collinear. So even if it looks like J, K, and L, there could be a line connecting them. Without it drawn, we don't know for a fact they're collinear. We cannot assume without measurements that we have parallel lines. Here, it looks like N and M are parallel, but without measurements or angle measures, we cannot assume that. And we cannot assume the exact measures of angles or segments without them being provided. So we would need labels or measurements given. So if we look at example 4 here, in example 4, we have the directions to examine the figure at the right. They tell us line T intersects lines M and N. The rest is up to us to tell if we can assume it or not. So can we assume that point T is on line N? Well, here's line N. Point T is drawn on it. So yes, we can make that assumption. Can we assume lines M and N are parallel? Nope, we don't have 90-degree symbols. We don't have angle measures. In C, point T is between A and E. So A, T, and E are all drawn on the same line. T is between the endpoints A and E. So yes, we can assume that. J, K, and L are collinear. They look like they could be, but there's no line drawn. So we would say no, we cannot assume that. In E, it says angle JIK is greater than KIE. Now, from looking at it, it looks like it's greater than, but without measures, we cannot assume that it is. In F, we have A, I, and E are all collinear. A, I and E were all drawn on the same line, so yes, we can assume they're collinear. And finally, point G, or example G, says angle JIT is a right angle. J to I to T looks like a right angle, but without the right angle symbol or measurements, we cannot assume that. So as you go through today's lesson, this table about assumptions from drawings will be important. And then all the different pieces from the top about the idea of angles, different classifications of angles, and the idea of arcs, minor arcs, and major arcs.